Hi. Sorry about the little delay with the questions. I missed one day because today was like all of my finals, so I was focusing on that. But hopefully, I'm done with that now, so I should be fine to upload on schedule. And then also about this day, I did copy like a lot of my code from Jonathan Paulson's solution. If you look on Reddit, you can definitely find him. He had a very nice solution, and I definitely drew a lot of inspiration from that. But yeah, so that out of the way, let's go ahead and look at the question. Basically, this is kind of like one of those like Picto like games where you basically have to see how many possible ways you can fill this up. And then so for example here we have a 1, and then a 3. And then once we have these question marks, we need to see how many possible combinations. So this is pretty much a DP question, and then part 2 kind of guarantees that because you end up getting your input 5 times in a row, and so brute force will just die. So let's go ahead and start writing this in DP. So first things first is we're going to go ahead and parse our input. So we'll create a function called def parse line. I'll take an L, and then here we'll do left-hand side, right-hand side. So here, let me just go ahead and first show you what this is going to look like when calling it, because maybe that'll make more sense. We'll do inputs, so go to parse line, L for L in input.split lines. So it'll be something like this. So now with each of our lines, let's go ahead and split this up, and what we're going to do is we could just do line.split, but one little optimization we could do here is here. If you look here, whenever we have these long stretches of periods, we could replace all of these with just one period. And this would make our inputs significantly smaller. And especially with stuff like this where it kind of compounds, I kind of want to do that. So let's go ahead and do that here because it's pretty easy. So we're going to use regex for this. And we're going to do L is equal to re.sub. And don't worry too much about this. You don't need this line. But what I'm doing here is I want to look for my period, and I have to escape it because it's a special character in regex. And if I find any number of periods that's greater than 1, I want to replace it with just one period. And I'll replace this with my line. So if I go ahead and print out my line, let's go ahead and see what we get. So here you can see basically we no longer have more than 2 periods at once. All of these kind of like extra spaces like here, you can see, get replaced with just one period. That's just a little quirky little optimization we can do. But so now let's go ahead and split this into our left and our right side. And then one cool trick that I saw from someone else's solution is to parse the numbers, we can just call it eval on the right-hand side. And so if I go ahead into the Python interpreter, if I do eval, it basically just directly like evaluates the code that I pass into here. So if I do like print test, something like this, you should probably, here, it calls that code. And so if I eval 1, 2, 3, 4 like this, it actually reads it like a tuple, which is pretty cool. I didn't know that. So we can just eval all of this right-hand side, which will read as a tuple. And then our left-hand side is basically just going to be the same string. So we'll go ahead and now return these. So we'll return our left-hand side and our nums. And this will inherently turn into a tuple when I return it. All right, so now we're reading our inputs right. If I go ahead and print my imps, just to sanity check, we can see we get something like this, which is good. All right, so now let's go ahead and actually write down the meat of our question, our solve function. So def solve, and it's going to take in our line, our nums, and then that's it for now. And inside of here, we're going to do something a little bit crazy, but we're going to create a new function. And I'll get to this in a second, and let me just make this so it returns. And then also we're going to need a DP, which is like a caching kind of thing, so that we don't recompute values we've already seen, which is going to be a map. All right, so in Python, I can define functions inside of other functions. They only just exist in this scope. So once this function goes away, this function definition also goes away. But other than that, this is fine. And this function can actually access stuff like this, and I can access this DP. But okay. So now with that off the way, what this function is going to be is it's basically a, it's just like a little helper function, but given this I, and maybe it'll help if I copy over my comments from my solution here. But here, if I could copy it, cool. Oh, oops. All right, here. So what the parameters are going to be is we basically get some line of our characters, and we get some list of numbers. I is going to be our index in the line where we currently are. N is going to be our index in these numbers, and B is going to be how many current, like how many current blocks we are building at this kind of state. And so imagine this as like a kind of state in time we can be at, and this is going to be our keys in our DP. And this might make a little bit more sense as we write more of the function, so don't worry too much if you don't get it here. But so here, first of all, we'll see if this tuple of our parameters is in our DP. If it is, we'll go ahead and just return whatever value we saw. So this is basically how we avoid recomputing values. All right. And so this is avoiding that. And then now let's go ahead and start writing the kind of logic for this code. So one case that we can just directly get out of the way is when we end up with our I being whatever the length of our line is, meaning we've gone through every input. So if I is equal to the length of line, then we want to go ahead and we want to return 1. So this function should be returning how many solutions there are from this position. So if we are at the end of our line, meaning basically we're done iterating through everything, we can return 1 if n is equal to our len of nums, meaning we've satisfied every single number in this list, and we don't have any current blocks. If we have a current block, that means we're basically trying to fill up an extra string, that's a string that's left over. Or if we have n is equal to the length of nums minus 1, like we're still missing one block, and our b, the current block that we're building, is exactly the last block we need. And it'll make a little bit sense when you see the rest of the code why we need to add this, but it's more like an implementation thing. But so let's go ahead and we'll wrap all of this in the int function. And so by doing this, it basically turns trues into ones and falses into 0, which is what we want, and we'll return this. Here, let me do this so it's formatted nicely. But so here, if, basically what this is saying is if we call this function and we are at the end of the line, if we've either filled up all of the numbers, like we satisfied that, and we have no blocks left over, like we're not building any blocks, then we can return 1. Or if we have, we're missing all but the last block, and that's the one we're currently building up. All right, so now this is basically like our end of line case. And so now for anything other than that, let's go ahead and create some answer variable, and we'll go ahead and just return that right away. And then here, we'll create our kind of DP where we save our answers. So by the time we get here, right before we return, we're going to save this to our DP. And it might help just conceptually if I kind of show that we are finally returning this, which is basically saying, hey, return how many solutions there are given this line in numbers, given that we've just started the string, we haven't gotten any blocks finished yet, and we currently are building no blocks. And like this building blocks is basically seeing how many contiguous hashes we have. So like for example here, this would be we're building 1 block, and then by the time we're here, we're building a block of size 2 and a block of size 3, and so forth. Okay, so now inside of here, this is kind of the meat of this. What we'll do is if this line is, so if our I is equal, or sorry, if the current character we're at is in either this, so basically if it's either one of these characters, let's go ahead and treat it like a period. Here, then if currently we are not at a block, so this is saying we're not currently building a block, nothing like that, then let's go ahead and add to our answer whatever we would get if we just kept moving forward. So this is basically saying, all right, just move one character forward. We still are at the same position of how many of these numbers we've consumed. And we also haven't started building a block either because we're at a period, or treating it like one at least. All right. And then otherwise, this means that we currently were building up a block. B is not 0. If our number, or sorry, here. If, here, I'll put this condition first so it makes a little more sense. So we'll have this. If the block that we're currently building is exactly equal to the size of the block that we should be seeing, whatever our current number is, then that means it's good. And we'll go ahead and close off this block because we're currently at a period. So we'll go to the next index, we'll go to the next number, meaning we kind of finished one block, and we reset our counter for how many blocks we've seen. So now one problem is this might go out of bounds, because what happens if we end up with like a solution like this, And then we end up with, or here, let me see, like something like this. What happens if I just put like a hashtag here, hashtag here, hashtag here? Eventually our code will run up, it'll keep looking for more numbers and index out of bounds because we only have 3 numbers. So in that case, we'll say if if n is equal to the length of numbers, meaning we've ran out of numbers and we're trying to look for more, go ahead and return 0. And this is saying basically, hey, like you're guaranteed not getting any more solutions, you're finding more blocks, and you've ran out of how many blocks you should have. So that's there. And then now, so these are all the cases we have for if we treat it like a period. Now, if we treat the line like a hash, and the question mark is because it could, like we could treat it like this. And by making both of these ifs, we're trying both of these if we get a question mark. If we treat it like this, then we check again. Or the only thing we really need to do is we move our answer forward, or we add to it at least, by moving it forward, n and b plus 1. And this is because we can't really close off a spring and check and like use one of these numbers because we have to keep going if we see one of these, if we treat it like a hashtag. And so we just keep add one to this. All right, so now I believe that should be it. If I go ahead and run this in the test case, all right, let's go ahead and see where the syntax error is. Oh, it's not supposed to be an or here, it's a comma. Or no, this should be an or. But this should be wrapped in this so that it's not ambiguous. And then there is a syntax error here because that is supposed to be an and. All right, and then we never call solve. So let's go ahead and call this here. So we'll call solve, and we want to sum up all of these. So we want to sum up solve on each line and number for line and number in ints. Or numbers, not numbers, sorry. All right, let's see what exception we have. And I can get rid of this now. Int has no len. Oh, len n. This should be len nums. Sorry, here. And DP is not defined. I misspelled that. Wow. All right, here. And so we can see the answers that we get are 6 and 21. If I look here, the answer here is 21, and the other one was just a kind of dummy example. So now if I go ahead and submit my code, boom, we get the right answer. I'll get rid of this line here. Nice. All right, so now part 2. For part 2, all we need to do is we basically need to multiply our input numbers by 5, like we just loop it, and then our input string, we need to match it, or we need to multiply it by 5 and split them with this question mark. So this actually becomes really easy because we can just do this. We'll do part 2 is equal to false, something like this. And then if part 2, then what we'll do is nums, since it's a tuple, you can just multiply by 5. And then line is going to be equal to, because line is a string, we'll just do this dot join, which will basically say, given some iterable object here, turn it into a string and put this in between all of them. So then now we'll go ahead and with the string, we will do our line and we'll multiply this by 5. So we get a list of line 5 times, and this basically just joins it. So we get our 5 lines all separated by this. So now if I go ahead and just copy this over, and then I'll go ahead and specify that this is part 2. Let's see what we get. If I run it on the debug test cases, we get 52512, 52512. And if I run it on my actual submission, it takes about a second, which is unfortunate, but we do get the right answer. So yeah, let me know if you have any questions. I'll try to clarify things up. Good luck.